All right, everyone, get ready because today we're going deep into the world of LLMs. But not just any LLMs, we're going beyond pre-training.
Yeah, we're going to crack open this research paper, LLM Post-Training, a deep dive into reasoning large language models. And we're going to explore how these models are being shaped into really powerful reasoning machines.
So for all of you AI fans out there, think of this deep dive as like your shortcut to understanding the cutting edge of LLM research.
Absolutely. In the first minute, we'll give you that need-to-know summary of the paper's insights. It's really focused on three core post-training strategies: fine-tuning, reinforcement learning, and then test time scaling.
This paper really goes deeper than just the hype and looks at how we can push these LLMs past their initial capabilities.
Exactly. And we'll explore how these techniques can address some of the limitations of pre-training, like potential for biases, the lack of task-specific expertise, and then those difficulties with logical reasoning.
And we'll also get into how methods like reinforcement learning, which is inspired by how humans learn through rewards, are being used to optimize an LLM's decision-making process.
And what's really interesting is how researchers are using scaling methods at test time to make even smaller LLMs perform like their larger counterparts on certain tasks without that huge computational overhead.
So by the end of this, you'll have a solid grasp of the state-of-the-art in LLM post-training, and that will give you an edge in this fast-moving field.
Sounds good. Let's get started.
Okay, so pre-training is obviously the foundation, but as you mentioned, it's not the whole story. Why is post-training so important even though these LLMs have already been trained on so much data?
Well, you can think about it like this. Pre-training gives the LLM a broad understanding of language, but it's kind of like having a Swiss Army knife. It can do a lot of things okay, but it's not really specialized for any one particular task.
So like a jack of all trades, master of none.
Yeah, exactly. And that's where the post-training comes in. It's about taking that Swiss Army knife and sharpening the blades for specific jobs.
So first up is fine-tuning. It's basically about tailoring these LLMs to specific domains or tasks, right?
Precisely. Let's say you want an LLM that can analyze medical texts, like a pro. You'd fine-tune it on a data set of biomedical research papers, clinical notes, maybe even some textbooks.
And that's how we get specialized models like BioGPT, which is designed for understanding and reasoning about biomedical information.
Exactly. BioGPT can answer complex questions about genes, diseases, and treatments. And in finance, there's FinBERT, which can be used for things like sentiment analysis and risk assessment.
So fine-tuning is like giving the LLM a crash course in a specific field.
Exactly, but there are challenges. One major hurdle is what's known as catastrophic forgetting.
Catastrophic forgetting sounds pretty intense.
It can be a bit of a headache. It's essentially when the model in learning new information starts overwriting previous knowledge, almost like cramming for a test and then forgetting everything a week later.
Oh, I've definitely been there. So it's a trade-off.
Yeah.
You gain expertise in one area, but maybe lose it in another. How are researchers dealing with this?
Well, there are some interesting approaches being explored. One is to use regularization techniques during the fine-tuning. Think of it like putting a gentle leash on the model's parameters so they don't change too drastically.
So it's about finding that balance between learning new things and remembering the old. What about the cost? Fine-tuning these massive models can't be cheap.
You're right. Computational cost is a big concern, but researchers are developing solutions like parameter-efficient fine-tuning techniques like LoRa.
I've heard of LoRa. It's like a shortcut that lets you fine-tune with fewer parameters, right?
Exactly. It's like adding a turbocharger to your fine-tuning process. You get the performance boost without having to rebuild the whole engine. This makes it possible to fine-tune even on less powerful hardware.
All right, so fine-tuning is about specialization. What about reinforcement learning? This one seems interesting because it's based on how we learn through rewards.
Reinforcement learning, or RL, is about refining an LLM's decision-making. We basically reward the model for producing outputs that align with human preferences.
So instead of just producing statistically likely text, it's learning to create responses that are useful and make sense in a specific situation.
Precisely, but RL with LLMs is very different from traditional RL applications like robotics or games.
How so? What makes it so different?
Well, first of all, the action space is enormous. We're talking about choosing from a huge vocabulary of words, not just a few physical actions.
Right. It's like the difference between picking up a block and writing a poem.
Exactly. And then there's the problem of rewards. They can be subjective and delayed and often based on multiple goals. Like, think about it. What makes a response good? It might need to be informative and harmless and engaging and who knows what else all at the same time.
That sounds like a nightmare to figure out.
It can be, and that's where techniques like RLHF come in. That's reinforcement, learning from human feedback.
Okay, RLHF, break it down for us.
RLHF is all about using human judgment in the training process. We collect data where humans rate how good and helpful the responses are, and that feedback is used to guide the RL algorithm.
So we're training the model to please its human judges, in a way.
Yeah.
But it's more than just pleasing them, right? It's about aligning the model with our values and expectations.
Exactly. We don't just want grammatically correct sentences. We want LLMs that understand how humans communicate, that are helpful and safe and appropriate for the situation.
All right, so RLHF is a big deal in LLM research. Now, the paper goes into specific RL algorithms that are used like PPO, DPO, and GRPO. Can you give us a rundown of those?
Sure. PPO, or Proximal Policy Optimization, is a popular algorithm that's known for being stable. It makes small updates to the model's policy to make sure the learning process is smooth and reliable.
So it's kind of like a cautious optimizer, making sure not to change too much as it explores all the possible responses.
That's a good way to put it. Then there's DPO, or Direct Preference Optimization. This one's more straightforward. It skips the need to model a reward function and learns directly from what humans prefer.
So DPO is all about efficiency and finding out what people actually like.
Exactly. And then we have GRPO, or Group Relative Policy Optimization. This is newer and has shown some really promising results.
GRPO was a key part of DeepSeek R1, which showed really impressive reasoning without needing supervised fine-tuning. What's the secret there?
GRPO's innovation is that it figures out the baseline reward from a group of LLM outputs for the same question.
So it's like a team effort where multiple outputs help with learning.
Exactly. This group-based approach has some benefits. It makes the learning more stable and simplifies the training.
So GRPO is all about teamwork and efficiency in the RL world.
Precisely. Now, beyond these algorithms, the paper talks about an alternative to human feedback. RLAIF, which stands for Reinforcement Learning from AI Feedback.
Wait, so we can train LLMs to critique each other?
That's the idea. Instead of always relying on human input, which can be expensive and time-consuming, we can use another powerful LLM to give feedback during training.
This is blowing my mind. It's like we're creating a whole ecosystem of AI models that are learning from each other.
It's a really exciting area of research with huge potential for scaling up LLM training. Imagine being able to train AI with AI that opens up so many possibilities for even more complex and capable models.
This is all super insightful, but let's be real. All this reinforcement learning must be computationally expensive. How do they manage the resources, especially with these huge models?
That's a great point, and that leads us to the third strategy for LLM post-training. Test time scaling, or TTS. Instead of making the model bigger or training it for longer, we're optimizing how we use it at inference time.
It's like having a powerful engine and learning to drive it more efficiently.
Exactly. The paper looks at different TTS techniques, starting with a familiar one, beam search.
Beam search. It's a classic decoding strategy that looks at multiple response paths, trying to find the most likely ones. It's like planning a trip and carefully thinking about all different routes before you go.
That's a good analogy, but for reasoning, beam search can be limited. That's where more advanced techniques like best of n search come in.
Best of n, if I remember right, is kind of like a competition. You generate a bunch of outputs and then choose the best one based on certain criteria.
Exactly. It's like having judges evaluate different responses and pick the winner based on things like relevance or coherence or even factual accuracy. And it lets us refine the model's output without retraining, just by being smarter about how we choose the final response.
So best of n is about making the most of what the model can already do. What about chain of thought prompting? Does that have anything to do with reasoning?
Absolutely. Chain of thought prompting is a really cool technique that encourages the LLM to break down tough problems into steps, which makes its reasoning process easier to understand.
It's like showing your work on a math problem instead of just giving the answer. You explain how you got there.
Exactly. And this can really improve the LLM's reasoning on things like math word problems or questions that need multiple steps. It's not just about the right answer. It's about knowing how the model got there.
So chain of thought prompting is about guiding the model towards more structured and clear reasoning. The paper also mentions this technique called self-consistency decoding. How does that work?
Self-consistency decoding is a clever way to use the model's own diversity to be more accurate. Instead of just going with the first reasoning chain it comes up with, it tries out multiple chains and picks the answer that shows up most often across those chains, kind of like a majority vote among different paths.
So if multiple paths lead to the same answer, it's probably the right one.
That's the idea, and it's pretty efficient because it only needs extra sampling during inference, not more training.
That's smart.
Yeah.
Are there other more advanced techniques that go beyond these basics?
Oh, yeah. We're just scratching the surface here. There are some really cutting-edge approaches like the tree of thoughts or TOTI.
Tree of thoughts. That sounds intriguing. What's the tree all about?
Imagine a tree where each branch is a different thought or step in the reasoning process. 2T explores this tree of possibilities to find solutions to complex problems, letting the model consider different options and choose the best one after a deeper analysis.
So it's like giving the LLM a map to find its way through all the possible solutions.
That's a great way to think about it, and there's even a more advanced version of 2T called the graph of thoughts, or GRPO. It allows for refining those thoughts over and over, which leads to even better solutions.
Wow, so this is getting pretty sophisticated.
Yeah.
GRPO allows for more dynamic reasoning and flexibility.
Exactly. It's like going back and revising your work, adding new insights, and correcting mistakes.
Okay, so 2T and GRPO are all about giving LLMs more time to think. But are there any techniques that come from other areas of AI?
Yes, researchers are even looking at using Monte Carlo tree search, or MCTS, which has been really successful in game AI.
Wait, so we're using game-playing algorithms to make LLM reasoning better?
You got it. MCTS is being adapted to look at and evaluate different LLM outputs, especially in situations where things are uncertain.
That's incredible. So we have all these TTS techniques, each with its own strengths. How do we know which ones work best? How do we evaluate how effective these different post-training methods are?
That's where standardized benchmarks are important. Researchers have developed all sorts of benchmark data sets to test LLMs on specific skills like reasoning or alignment, or how well they work with multiple languages and their overall understanding of language.
So it's like a testing ground for LLMs where we can compare how they do on different challenges and see which post-training techniques are making the biggest difference.
Exactly. These benchmarks give us a way to measure how much progress we're making in the field and see how effective new methods are, and that's what we're going to dive into next.
Okay, let's get to it. I'm really curious to see how these LLMs stack up against each other on these benchmarks.
Okay, so let's look at these benchmarks and see how researchers are figuring out how good these post-training techniques are. We'll start with reasoning benchmarks, which, as you might guess, are about seeing how well an LLM can think logically and solve problems.
So it's not enough to just create sentences that are grammatically correct.
Yeah.
We want these LLMs to understand and reason about the world, right?
Exactly, and that's where benchmarks like math come. In this data set gives models all kinds of math problems, from basic arithmetic to more complicated word problems.
Okay, so if we want LLMs to help us in fields like science or engineering, they need to be good at math. Yeah, it makes sense.
Absolutely. And then there's GSM-8K, which uses grade school math problems, but they're written in a way that needs multi-step reasoning and a bit of common sense.
So it's testing if the LLM can not only do calculations, but also understand the ideas behind them and how those ideas connect to real-world situations.
Precisely. And if you really want to push the limits of LLM reasoning, there's MetaMath QA, which is all about proving theorems and those abstract mathematical concepts.
That sounds intense. Are there benchmarks that go beyond just math?
Definitely for scientific reasoning, there's WorldTree V2, which tests models on how well they understand scientific ideas and if they can draw conclusions from scientific text. Imagine an LLM that can not only read and understand scientific papers, but also come up with hypotheses or plan experiments.
That'd be amazing for scientific discovery.
It would, and as LLMs are used more with other things like vision and audio, we're seeing multimodal reasoning benchmarks pop up. The paper mentions MMMU, which tests how well models can reason about both text and visual information.
So we're talking about LLMs that can analyze scientific papers, understand the diagrams and figures that go with them, and then draw conclusions based on all of that.
Exactly. It's about pushing these models to think about the world in a more complete and human-like way.
Okay, so we've got reasoning benchmarks covered. What about RL alignment benchmarks? Those are about making sure these LLMs are not just smart, but also safe and aligned with our values.
Right. We want these models to be both intelligent and well-behaved. And RL alignment benchmarks are made to evaluate how well LLMs stick to human preferences and don't create outputs that are harmful or biased.
So it's like checking the model's character as much as it's intelligent.
Exactly. We're not just building powerful tools, we're building partners and collaborators, and that needs a certain level of trust and alignment.
Can you give us some examples of RL alignment benchmarks?
Well, there's Help Steer, which measures how well a model can give helpful and informative answers. It's pretty basic for any LLM that's going to interact with humans.
For sure, we want these models to be useful and give us something valuable, not just random text.
Exactly. And then you have ultra feedback, which looks at how well the model can understand and respond to feedback from users. It's not just about giving a good first answer, it's about being able to adapt and improve based on what humans tell it.
So it's like being a good listener and learner, which are important for any AI that wants to work with us.
Exactly. And if you're interested in the technical details, there's Anthropic's RLHF, which looks at how well models learn from human preferences through reinforcement learning.
So it's about understanding the nuts and bolts of how these models are trained to be in line with what we value.
Precisely. And as LLMs get more powerful and become part of our lives, these RL alignment benchmarks are going to be even more important. We have to make sure these models are not just intelligent, but also responsible and trustworthy.
Now, what about testing with multiple languages? I know a lot of early LLMs were mainly trained on English data. Are we seeing more models that work with multiple languages now?
Absolutely. People are realizing that LLMs need to understand and generate text in more than just English. It's about making these technologies available to everyone around the world and making sure that AI helps everybody, not just English speakers.
That makes a lot of sense. So how do researchers test these models to see how well they work with different languages?
Well, we have multilingual evaluation benchmarks. Of course, these are designed to see how well LLMs work across different languages and cultures. It's not just about translation, it's about understanding all the little details and differences between languages.
Right, because different languages have different grammar, idioms, and even cultural contexts that are important.
Exactly. One example is Culture X, which tests models on things like translation and question answering in over 150 languages.
Wow, 150 languages. That's amazing.
It is. And then there's Pangenes, which looks at how well models can follow instructions in multiple languages. It's about making sure that these LLMs can not only understand different languages, but also respond correctly to commands or requests in those languages.
So it's about making sure they're not just multilingual, but can also interact with people from different language backgrounds in a way that makes sense.
Precisely. And these multilingual benchmarks are really important for making sure that LLMs aren't just tools for English speakers, but can be used to help people who speak all kinds of languages.
Okay, so we've talked about reasoning alignment and how well they work with different languages. What about general comprehension benchmarks? Those seem pretty broad. What exactly are we testing there?
General comprehension benchmarks are about looking at how well the LLM understands language overall, and if it can do a wide range of tasks that need natural language processing. It's like a big test of the model's language skills.
So it's like checking the model's general knowledge, common sense, and how well it can reason about the world as a whole.
Exactly. Benchmarks like big bench test models on a bunch of different tasks like question answering, summarizing, translating, and generating dialogue. It's like an AI decathlon for LLMs, testing how versatile they are and how much they know.
I like that. So it's about making sure these LLMs are well-rounded and can handle different language tasks in the real world.
Precisely. And then there's MMLU, which stands for Massive Multitask Language Understanding.
MMLU sounds like a real challenge.
It tests models on their knowledge and reasoning skills in 57 different subjects, from basic math to law to computer science.
Wow. That's a lot to cover.
It is. And these general comprehension benchmarks are super important for seeing how much progress LLMs are making overall and figuring out where they still need to improve. We need to make sure these models aren't just good at specific things, but also have a strong base in understanding and reasoning about language.
Okay, so we've covered a lot here. Reasoning alignment, multilingual stuff, and general comprehension. Are there any other kinds of benchmarks we should know about?
Yeah, there's one more category that the paper talks about: dialogue and search benchmarks.
All right, let's hear about those. What are dialogue and search benchmarks all about? So dialogue and search benchmarks are testing LLMs in situations where they're interacting more and need to find information from outside sources, right?
Exactly. Dialogue benchmarks look at how well an LLM can have a conversation that sounds natural and makes sense. It's like testing the model's social skills and how well it can understand and respond in a back and forth exchange.
Okay, so it's not just about creating text on its own. It's about being able to talk to humans in a way that feels natural and like you're actually communicating.
Precisely. And search benchmarks are about seeing if the LLM can find and use information from outside sources, which is really important for things like answering questions, doing research, and gathering information.
So it's about testing if the model can access and process information from the real world, not just what it's been trained on.
Exactly. Some popular dialogue benchmarks are Condi AI2 and Multi-WOZ. These focus on how well the LLM can keep track of the conversation, understand what the user wants, and give helpful answers in a chat setting.
These benchmarks seem especially useful for things like chatbots, virtual assistants, and even tools for education, where the LLM needs to be able to interact with users in a way that's natural and interesting.
Absolutely. And for the search side, there are benchmarks like BER, which looks at how well the LLM can find relevant information from a huge amount of text. This is a key skill for any LLM that needs to access and use real-world information.
It sounds like these dialogue and search benchmarks are really pushing LLMs to have a deeper understanding of language and be better at interacting with the world around them.
They are, and as LLMs become more common in our digital lives, these benchmarks will be even more important in making sure that they can communicate well, find information easily, and ultimately give us the knowledge and help that we need.
This has been a really cool journey into the world of LLM post-training and evaluation. We've talked about the main techniques, the different benchmarks, and the interesting research trends that are shaping the future of this field.
And we've seen how all this progress is pushing the limits of what AI can do, opening up possibilities for LLMs that are not only more powerful, but also more aligned with what we value and need as humans.
So as we wrap up this deep dive, what's the most important thing for our listeners to remember about LLM post-training?
I think the key takeaway is this LLM post-training is where the real transformation happens. It's the process that takes these basic language models and turns them into powerful, specialized tools that can change different industries and parts of our lives.
It's like having a block of marble and turning it into a work of art. The raw material is there, but it takes skill and creativity to make it into something amazing.
That's a perfect analogy, and as research in this area keeps moving forward, we can expect to see even more incredible advances in the coming years. Who knows what we'll be able to do with these increasingly sophisticated and capable LLMs.
It's an exciting time to be working with AI, that's for sure. And for everyone listening, keep exploring, keep learning, and keep pushing the limits of what's possible with this awesome technology.
And as you keep learning and exploring, here's something to think about. With all these advances in post-training techniques, could the future of developing LLMs move towards training smaller, more specialized models that are fine-tuned for specific tasks instead of using these giant one-size-fits-all models? Could we see a world where LLMs are more like specialized tools in a toolbox, each one made for a specific job?
That's a really interesting question. It makes you think about the future of LLM development and how we can get the most out of these powerful technologies. Thanks for joining us on this deep dive into the world of LLM post-training. Until next time.
It's been great exploring this with you, and to all our listeners, keep pushing the boundaries of AI.